Awesome. So I'm Austin, but I'll introduce myself in a second. So I want to start with this. I'm going to come back to this quite a bit. So Web3 has a state management problem. How did we figure this out? This is really interesting because, so I'm Austin, I'm from Owen Labs. Our team is like the labs company that built the Mina Protocol. So ZKOGs, does everyone know Mina? Just like quick show of hands, have you heard of Mina? Okay, sweet. All right, then I'll go quick over this. But yeah, so Owen Labs built a protocol. They built a lot of developer tooling. Mina is cool because it's sort of like the first example of a ZK rollup, really, and it's a succinct blockchain, and that's the bit that we're extremely proud of. Built our own proof system, built smart contract frameworks on top of it with ONJS and all of that stuff. And so going back to the original question, where did we arrive at this state management challenge? And I'm gonna give us I'm gonna give Mina a report card basically. How are we doing in terms of serving applications? And when we bring it back to Owen's vision, our vision from O1 is to enable an internet of applications that use programmable cryptography, and Mina is a huge chunk of that. And that's the first bit, which is the settlement layer, and that's Mina. And that bit actually works really well. It's operational. It's been in mainnet, zero downtime. There's actual applications using it. So I'll give us a pretty good passing grade on the settlement side. Application execution, I'll give us a good grade. We're doing okay. We've got ONJS, you can write smart contracts, you can write circuits. All of the executions off chain. Obviously, we're at Async house, so that kind of makes sense. And maybe in the future there'll be something with on-chain execution, but that's not the purpose for today. But then this third bit, state management. I don't really give us a passing grade here. So I want to really dig into specifically Mina has a state management problem. What do I mean by that? And every time I talk to an application developer in Mina, they're wondering, where do I put my application state? So Mina, since it's so small, there isn't much space on chain, so they actually need to rely on something else. And they're not really met by a great deal of solutions in market. They'll use something that is meant for persistent storage, but then they have to keep adding new allocating new chunks of data every time they want to write to it. And they really want something that's optimized for decentralization, low storage cost, and low latency. I'll kind of drive this home with one of the application examples. So there's a game called Tileville, and you can think about it like Settlers of Catan, basically. So it's you basically swap tiles and organize these in a fashion where you connect that river on one end to the houses and everything, and you get points basically. For all intents and purposes, this is an 11 by 11 grid that can be represented by a matrix, right? That's the game state. So I was talking to the founder of Filecoin, of Tileville, and he's I want to store my game data somewhere, but right now I'm just throwing it in an S3 bucket, and it's pretty centralized. And I'm running these tournaments where people are basically sort of staking some Mina, and then I'm paying them out afterwards. But the game data can kind of be disputed, and I respond back to them. I'm okay, great. Have you tried using some other things? And they're yeah, some of these IPFS things are just either pretty hard to integrate with. And every time I have a game exists and I have another game, I have to keep adding and appending to this large pool of state, and I don't want to deal with any of that. So how are we going to solve their problem? And what we've realized is that's one state management problem just for Mina. When we took a step back, we realized, oh, this is actually a problem across all of Web3. There really isn't a great solution for state management across Web3. Mina's not alone by having prohibitively small or very expensive on-chain state that's hard to work with and expensive for your application. So there were no scalable solutions for state management, and I'll go into our beautiful solution. Go ahead.
I'm just curious why ceramic doesn't work for this.
I haven't looked into ceramic specifically. Do you?
I think that's kind of the point of. It's been around for a few years. I don't know. Yeah, I don't know. We talked.
Okay. Yeah. Let's come back to it. So our approach to this is what we're calling Project Untitled. The name is coming, so just wait around for the name. We were too busy building it to actually think about branding it and naming it. So the thing I want to underscore is that this is the mutable state solution that's powering the next generation of open web applications. And it's going to be built by us. So what it's going to be is a dedicated L1 that has its own sort of economic layer, and it's going to be accessible from every ecosystem. So it's not going to be just Mina specific, it's going to be ecosystem agnostic. And it's built on the back of polynomial commitments so that we can enable scalable state updates for just the bits that you want to change. And so like the first bit that I just want to like draw specific attention to is mutable state management. So like, what does that actually mean? The mental model that I try and give everybody is like, think of it like state diffs. Like when you're like committing some code to a repository, like you don't just rewrite the entire repository every time you make like a one-line change. Like you just like you commit the diff, right? Like and so why can't memory or sorry, why can't storage or any like application state management follow a similar model? So I think of this concept of like state diffs, like just changing what you need to. The beautiful bit about that is that if you change just the bit that you actually have to update, then you always have the most updated state. And when we were talking about data availability a lot, like in the last like 45 minutes, you can think of the comparison when you're thinking about this in comparison to data availability is just the latest data is always available, and it's like O of 1 complexity in order to achieve in order to go and grab that data and verify it, which is different than like if you're relying on DA, where like loosely defined like data availability is about like having transactions so you can replay them and get the latest state. Like doing all that is work, so we can do it in O of 1 time by carefully picking our polynomial commitments and managing our updates. So I'll just I don't want to talk too deeply about this, but this is just to sort of like broadly indicate that it's going to be a standalone protocol. So like you've got the basic flow. This shouldn't be super groundbreaking for anyone in this room. It's you've got your base chain. User submits a transaction. There's the application smart contract that processes the interaction, sends a message to like some bucket, so some project untitled bucket. That gets picked up by node operators that it can fetch the current app state. The node then processes the transaction, sends the execution proof in a state diff, and then the new state is committed back and sent back to the application contract, and then the application can sort of like process all the side effects that it wants. So you can think about it as like the project untitled network is a standalone network that's like ecosystem agnostic. So we think that like there is still this state management problem, but you can solve it with permissioned mutable state management, and that's what we're going to target. So I want to kind of like tell a bit of a story. So this is like I'm breaking out of like pitch mode, and I want to talk about like where this could go in the future and why we think that like mutable state management that's permissioned is important. So is anyone local to Denver? Did everyone fly here? Yeah. Okay, so I was thinking about how I got here, and I was on Gemini, and I was just like, write a photo of like some typical travel experience to a conference, and like, what it spat out was a guy that like doesn't actually look like me, but because like I definitely don't own a car, and I definitely don't have a lawn, so this isn't me. I'm starting to get some gray hair, but like this is what the agent thought who I was and who I was trying to be when I was asking it this question. And I was thinking about this in the context of like what I wanted to talk about today, and it's like, it's kind of a good thing that this model didn't like know me in this instance. Like I actually don't want it to know who I am and like feed me exactly like what I am and like have access to all of my sort of like my individual state in like a weird way, right? And then so thinking about like the context of like this guy, like and how many agents I probably touched on my way here, right? Like it's ETHDenver, so like I mean, if I don't give a talk where I'm talking about AI agents, I think I'd get kicked out of the conference. But like just getting here, I called an Uber, I arrived at the airport, went through security, then I ordered food, then I actually flew, then I jumped on a train, did some work on the train, then checked into my hotel. It's like I probably touched like a bunch of agents like on the way through there, like just like even in Uber or like obviously like going through like TSA, like they took my photo and that probably went through some sort of like local agent, whatever that is. And so I'll loosely define this world of like AI agents as just like any sort of like bit of compute that's connected to some model, whether that's a big one or a small one, that does something on your behalf. And I'm oversimplifying this just to like kind of share this vision of the future, which is, do we think, like, and I genuinely want like an answer to this, it's a bit of a straw man, but like, do we think there's gonna be more or less when I come and do this trip in 2030? My strong hypothesis is there's probably gonna be more, and like there's gonna be more touch points, there's gonna be more agents, and I think like amongst the AI community, I think they're starting to realize that like the AI agents are going to sort of beat like just like having gigantic models with like single agents. So my bet is that there's gonna be more, not less. So then going back to like, okay, like this particular image was generated with that like context of me, like, okay, let's think about that journey. Like when I ordered my Uber, like by definition that Uber now has like my address, right? So I don't necessarily want that address to then also be shared with the same company that I ordered my food from. Like that just doesn't make any sense, right? And then similarly, like when I got to the airport and like I gave them my passport, like, you know what, I actually trust for this application, like I trust the Canadian, the US government, and like they can have that data prove that I'm safe and that I can fly, and that's okay as well. When I ordered food, like, and maybe I'm wearing like a smartwatch that's like monitoring my glucose or something like that, this gets like a little bit more nuanced because maybe I actually do want my Uber Eats or whoever I order food from to know that if they gave me too much glucose, and maybe I had like, it would spike or something like that, and I should probably manage my diet a little bit better. The reason I'm kind of telling this story is like all of those like touch points where I'm interacting with some sort of agent required me to share some of my state, like whether that's my personal state or whether that's something that's been derived from like a device or something like that. I think that that's going to increase over time. And in order to do that effectively, I want to be able to tell who can and cannot access that state, and I want to be able to do that in a way that I can actually trust it. This hopefully is now coming around. Like I think that the solution that we're describing when it comes to like decentralized state management is to be the backbone, the state layer to solve this problem of the future that's only going to increase. So what I want to leave everyone with is like we're actually building this thing. So like I went into sort of this what if land when I'm talking about like the future using agents. We're still building for the right now. So like Tileville, like in a bunch of other applications in Mina, they're waiting for just decentralized state management now. So there's like a practical first user for what we're building. We've shipped a white paper draft. So I would encourage you that have questions. Like my background's in product. If you have questions about how the technology actually works, the white paper, and there's good discussions on GitHub on that. We'll try and cover some of it now, but if you feel the need to read a white paper, like I would love you so much, and I would recommend you do that. And then finally, like our Discord, our Telegram, like we've got like hundreds of devs that are in there and they're discussing it and they're waiting for it now. So
Give the link to the white paper.
yeah. Let me do one of these actually. I will not be connected to the internet. Sick.
But it's in that repo, the Owen Labs project Untitled white paper.
Yeah, like I think if you Google like project Untitled white paper, it should.
You would have to pop into Denver if you
That's okay.
Did you want to get on the network?
All good. I think I can get this going quick. I think this should go to the white paper. Is this? Can you? Oh, whoops. If you can scan that or not. I'll flip it to you afterwards. I'll find you. So privacy is. I'm just gonna unplug this so we don't go. Whoops. Sorry. In what context? Like.
You have this permission state management. So I know my data is within my control, but I may not want my data to be readable by everybody.
Yeah.
So how do you guys?
Yeah, great point. So So the permissions will be on read and write access. So so you'll have it'll likely be on some sort of some application layer. So like whatever the equivalent is of like the ONJS like actual like application writing layer is, you'll be able to set your permissions for reads to be anyone, just this like set of people, and you'll be able to transfer those and change them. The other interesting side of that is with writes too, because like some people look at like only one person being able to update something. Like for example, like if I'm building a voting app, and like I ship this voting app once that has all these candidates, I don't even want to have the ability to sort of like overwrite and write that again. And like that might be a better like sort of fit for like persistent storage, but like that's the spectrum of like range that people can like expect to have control over there.
So like if I said only I have read access to this data, like I'm encrypting it, locally and posting it encrypted data on project Untitled.
Yeah, totally. Yeah.
Okay.
Yeah. Cool. I'm happy to answer any other questions about it, or about Mina, Owen Labs, how it all connects.
What were some of like the big problems in like designing that solution? Or I guess if there weren't really any big technical challenges, why don't you think somebody's done it before?
Yeah. So one of the huge benefits is that we built Mina, and like by building the proof system and like understanding polynomial commitments and like what they can do, we actually like there's a lot from the Mina the protocol repo that we can reuse for decentralized state management. So like like genuinely, it just happens to be that the polynomial commitments that we can pick very carefully are things that like our team has explored and uniquely explored. It's not like a completely novel idea. Like I do know that like Filecoin and some others have looked into using polynomial commitments, but they've had challenges with like actually doing it at scale. My direct response to that is that we've got like experience from building Mina, and we've got users that are going to be able to validate really quickly whether or not it meets their needs.
Yeah, I think, I don't know your name, but the ceramic, I don't think they did anything with like polynomial commitments, but I know that like a lot of what they tried to do is have like very granular read-write permissioning, right? So like, yeah, you could have, I think their main example was like a social graph, right?
Yeah. Through the interviews, like through talking to users, like permission seems to be just so like pertinent because everyone has a different expectation. So yeah.
How do you think about, or how do you architect for durability, right? Like one of those things when I store my data, so I want to make sure you don't lose it.
Yeah.
And there's all sorts of best practices and across how many you don't want it in one data center because that can go up in flames, and then there's erasure coding and all sorts of stuff. But
Yeah, so there's a few pieces to that. So like one is like the technical challenge. That's like the things like erasure coding and like the availability sampling and stuff like that. So like that's just like base requirements, like prior art. We're just gonna do that. The harder part of that is you're basically asking about trust, right? And it's like, how do you trust a storage solution? And like my honest answer is you don't initially until you have reps on it over time where you can then trust it. Some of that like bootstrapping of trust can be mitigated by like some projects very early on, just like running the infrastructure themselves and then serving the data back to themselves through the network, so that like it can just be like continuously like up. And like that's more of like a go-to-market strategy, which is like how much do you subsidize like those type of things just to build that sort of baseline foundation of trust. I don't think there's like a perfect answer for that, but I think it's just like like do the fundamentals, like copy some of the prior art that's already been used, and then over time, hopefully you can build enough trust that people put more and more state onto the provider. Yeah, I had the same question like whenever Filecoin launched in like 2016 or something like that, 2017. No, but whatever around that time, it was like, okay, if I'm like thinking about this like it's like the naive example of like my Dropbox, it's like how do I actually know that data is going to be there? And it's just like over time that goes down when you can build that trust. So.
What kind of like cost per gigabyte are you looking at?
Great question. We have a demo that just like interacts with the cryptography, and it runs on consumer hardware, so it seems to be relatively affordable. The actual like cost breakdown of what it costs to do like reads and writes, like we are racing to get to a test net so that we can like get an exact answer back on cost per gigabyte.
And do you price per storage, or do you also price per reads and writes?
Yeah, like this is a like open for discussion on like what the sort of like the price function is going to look like. Our current hypothesis is that it should be an open market dynamic between the state replicator nodes and the actual like application or whoever is like asking for state, and it'll be like a price function that takes in like how much and how often are you going to read, how big is your data, and how often and how much are you going to write. So it'll be some function across those three things that'll be like priced specifically based on the contract, but it's up to the application to basically like put an ask out. In that market.
So how does this work with like if I'm a user that's using an application that's using like your solution for state management, am I paying the fee for accessing the read, or is the company like is this contract, is there some kind of like pooled fund where the contract has to pay that? Like do I have to make an additional transaction to send over some whatever token to you? Do I have to hold your token in order to
TBD. Like all TBD. Like the cost will be borne ultimately by the application. So like they like the way that applications pay for storage, right? So like that's like a pretty familiar model, and like expectations from apps are to pay for that. Exactly like what the mechanism looks like, whether it's like locked up front or like paid in like sort of like a more dynamic fee, like as you read. Like I could probably give the simplicity argument of what's likely going to be the first version, but that we need to have more of a discussion with tokenomics experts on that one.
But like, cause like on ETH, when like users do pay for storage, but that's just part of like the gas fee, right?
Yeah.
But it's like it's kind of weird when like you have this other token that like you need to pay for storage with. Like, how does that work?
Yeah, like, I would just give the argument, which is like even that Ethereum application, if they had to put some data in like a bucket somewhere, they've got to pay their AWS bill. So like they're pretty used to like paying for storage or like managing state like separately.
Well, but not for like Uniswap. Like Uniswap.
That's true. That's true. Like blended fees, it's like I will never argue. Like it's a better experience. I'm just like we just haven't decided which model makes more sense. Yeah.
Quick question. So when you say sort of storing state diffs,
Yeah.
I guess are you overwriting the overwritten bits, or is it accumulating with every update?
Great question. So it's like I'll go back to like the repo example. Like your first commit is going to be like 1,000 lines of code, right? Like your second commit is going to be I actually just need to add some comments and change a few lines. So like you initially store that gigantic bit of data. Like you open up a socket basically to like transmit that data. Then the only thing that you store after that is like what has changed. So you actually don't have like the memory of what was there previously. And if you did want it, there's like the pattern that like most chains would use for this is just to run your own archive. And if you wanted to continue to have access to that previous data, by not doing the append only, what you're then able to do is have like that O of 1 like verification that current state is like the most is up to date.
So it is overwriting.
Yeah, yeah. Yeah, and that'll keep it small, and that'll keep like just the state that you actually need in order to use your application like the most readily available. Cool. Any other thoughts, questions? Sweet. Thanks for the attention. Oh yeah, of course.
What was the design choice behind making this a standalone layer 1?
Yeah, that's a great question. Like there could be a future where it is blended and like you do have settlement. Like honestly, it's like simplicity and speed to market. So like it would just like we'll be able to get to market like way quicker than like making huge changes to the Mina protocol that require consensus changes, consensus upgrades, and stuff like that. So that's like the primary driver. Yeah, that's not to say that it couldn't be blended at some point in the future, but